This is Dr. Holt. I want to go over how to generate a displacement versus time graph and a acceleration versus time graph when you're given a velocity versus time graph here. Alright, couple things to note is the area under the curve of a velocity versus time graph will give you your displacement. The slope of the velocity versus time graph will give your acceleration. So again, if you're looking to generate your acceleration, then you're going to use the slope of this to generate this. If you're looking to get your position, then you're going to look under the area of this to create your displacement. Alright, so just make sure you know that. Alright, so now we're going to go ahead and start generating some of this. Let me go ahead and take this out. Alright, a couple things. When you're doing this first, make sure you understand the coordinates of or the values of your axes. Here we have velocity we have velocity in meters per second. Each tick mark is 5 meters a second. So we're going to have 5 here, 10 here, 15 here. Do not get confused and make this 1, because if you do that, you're going to mess everything all up. Now our time, this will be our time. We come down here, each tick mark is 1 second, so we know this is 1, 2, 3, 4, and 5. Alright, to generate my displacement versus time graph, all I need to do now is find out the area. So what I would do here first is find out how much area I have between 0 and 5. Okay, so now to calculate that, I say, well, I have a rectangle and I have a triangle. The area right here would be my base, which is 5, times 5. That gives me 25. I calculate what this is. My base here is going to be 5. My height is going to be 20 minus 5, which is going to be 15. The area of a triangle is always going to be 1/2 base times height. So I take 1/2. I multiply it by my base, which is 5. I multiply it by my height, which is 15. 15 times 5 is 75, divided by 2. That gives me a value of what? 37.5. So I know that this area here is 37.5. I add those two together, that gives me 62.5. So all I have to do now is come straight up, find 5, which is right here, 1, 2, 3, 4, 5, and then go up and put a dot at 62.5. So each one of these is going to be, let's just check this. Each one of these is 25, so that's 25, that's 50, that's 75. I put a tick mark there. Now what you don't want to do is say, oh, I'm just going to draw a straight line between here and here. Because that's not the case at all. If you look here, your velocity is increasing as you go up. So as your velocity increases to go up, you cannot have a displacement versus time graph looking like that. It's going to look more like this, and I'll show you what it's going to look like. It's going to be closer to doing something kind of like a parabola. Kind of like that. Alright, now if you want to get really good, you can generate these points, and let me show you how to generate these points. You can find this point and this point and this point, and you can make this really accurate if you want. Because if I want to find out this point, let's say this point here, all I need to do is find out what the area of the curve is between 0 and 2. If I was going to do that, I'll erase the areas I already have so we don't get those confused. Let's take these back out. So I want to find out the area at 2. All I have to do is sit there and I draw this straight down to 2. I say, what is the area under the curve? Well, the base here would be 2. I go up 5, so this part here would be 10. What's the area of this? I got a base of 2. I got a height. Now you're going to have to approximate because you don't really know exactly what that point is. You could find out mathematically, but let's just make an approximation. We come up 5, we come up about another 1, so that's about 6. 6 times 2 is 12, divided by 2, that gives me a value of 6. So I know 6 plus 2, that's 16. So all I really need to do is come up here and I say, wow, that value has to be 16. Well, I know half would be 12.5, so I'm pretty doggone close. So if the question would ask you, For example, what is the displacement between 0 and 2 seconds? Well, then it would be 16, because all you're going to do is find the area. If the question would ask you, what is my displacement between 0 and 3? Find the area under the curve between 0 and 3. That's your displacement. Again, let me say one thing, though. That is not your position necessarily. If it tells you when time is 0, and it tells you your initial position, we'll say call it P or X, is 10, then what would be your position at time is equal to 2 would be 10 plus your 16, so your position would equal to 26. That would be P2. Now again, that's only if your initial position was given something other than 0. If your statement gives something like this, at time equals 0, say it says X or P is equal to 0. Say it says something like that. Your initial position is 0. Then your position at 2 seconds would also equal 16. Your displacement position would be exactly the same thing. Alright, so we've done a pretty good job drawing the curve up to there. Now all we have to do is come back down here and find out what the rest of this area is. We come over here. We count our times. This is 6. I'll come back to red. This is 6, 7, 8, 9, 10. What's my base? 10 minus 5. That distance right there is 5. What's my height? 20. That area has an area of 100. So I come up here to 10. I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put a tick mark. I got to go up from here. I need to go up another 100. So I know this value we said was 62.5. So I need to go up to 162.5. So I come up here, there's 100. 25, 50, I put a tick mark here. Now, the thing note here, if this line here is flat, then you're going to have a linear line. So I can just generate a linear line between here and there. And if I want to know the slope of this line, the slope will be the same thing as the velocity value. If this is at 20, then this will have a slope of 20. Alright. Now, let's find out what the area of this is. We get my pen back. We go ahead and calculate this area. I'm coming over 1. I'm going up 20. 20 times 1 is 20 divided by 2. That gives me 10. Now that does not mean I'm losing 10. I'm still gaining area of 10. So I'm at 162.5. So I need to go up another 10. That's going to be 172.5. And where did we say that was crossing? That's at 11 seconds. So I'm going to come up here. I know this is going to be 175, so I'm right about there. Now, I'm going to try to draw this accurately, but anytime the velocity versus time graph crosses this value here, what is your y value? What's 0? So that means your slope has to be 0, which means your curve has got to turn and go back off like this. Okay, and we could label that value there, approximately 172.5. Pretty close to 177. So we reached the vertex. Now we're going to start losing area. So we're going to have to find the area under the curve. Now what you don't want to do, and I've seen students do, they start calculating all this area down in here. That's meaningless. You need to calculate this area here. So I'm going to break this up into a rectangle and triangle. So let's find out what this little area here would be. Again, I've gone down 5, 10, 15. 15 times 1, I've gone down here. So 15 times 1 divided by 2 is going to be a negative 7.5. And it's negative because I'm below. So what's happened at the top? I got 172.5. I'm going to subtract 7.5. So I know I'm at 165. So when I reach 11, 12, tick mark here, which we said this would be 12, then I got to be back down to 165. And again, you're making close approximations, but we know this is 25. This is 50. We want to go to 165, so we're going to be somewhere pretty close to there. So this curve is going to curve back down like that. Let me see if I can draw that a little bit better than I drew it. Oh, still not very good. Let's do better than that. It's kind of hard to do when it's this small. It's going to be a curve like that. Okay. Now let's see what's happening here. Let's calculate this area here. We've gone down 15. We've gone over 1, 2, 3, 4, 5, 6. So 6 times 15, that's 90, right? So I've lost 90 more. So I take my 165, I subtract 90 from that. That gives me a value of 75. So I come over here. I'm at the end. I'm going to go back up. I'm going to go to 65. That's going to be 25, 50, 75. Again, oops, let me make a mark there. If this is flat here, then you're going to have a linear line. So I can just draw a linear line between here and here. At that point, I'm done. That is my displacement versus time graph. So what the value of this is, and once I have that drawn, I can find out where I am at any point in time as long as I know what my initial position is. Because if I know what my initial position is and I want to find out where I am, say at 10 seconds, I come up to 10, I find this value here, I come straight over, I take that value, I add it on to my initial position, and that's where I'd be at 10 seconds. Alright, so this is drawing the displacement. Now the good thing is, once you have a velocity versus time graph, the acceleration is really a piece of cake, and I'm going to show you how to draw this. So let's clean up some of this stuff and get some of this out of here. Just draw, okay, alright, I'll draw, let's see, eliminate some of the area calculations, because we don't need those either. Okay. Alright, so now let's draw the acceleration. Again, real easy. Okay. All we need to do now is find out what the slope is going to be of each one of these lines, and from doing that we can find the acceleration. If we look at this line right here, we can tell that this point here is going to be 20. So we write down 20, and we say, what is this value here? It'll be 5. So basically we're doing the final velocity here minus the initial velocity here. We're going to divide it by the same time interval. By the time interval. 1, 2, 3, 4, 5. So I'm at 5. My time interval here was 0. So 20 minus 5 is 15. 15 divided by 5 gives me a value of 3. So what that means is the acceleration, or the slope, of this line right here is going to be 3 meters per second squared. And the reason it's going to be 3 meters per second squared is because your velocity is in meters per second and you're dividing by a time that's in seconds. Alright, so all we have to do is come down here and we need to locate where 3 is going to be in our acceleration. We know each one of these tick marks here is going to represent 2. We've got 2, 4, 6, 8, 10. So we know 2, so 3 would be right in here. So I need to go over to 5. 1, 2, 3, 4, 5, and I put another tick mark here. So all I have to do now is draw a straight line, because my slope is constant all the way over to here. We'll make this blue as we go along, so there will be no confusion. Alright. So now we've done the acceleration between 0 and 5 seconds. To note, if you are if you're ever asked what the instantaneous acceleration is going to be between any of these time intervals, any of these time points, say at 1.5 seconds, then the instantaneous is going to be the slope of this curve. Well, the curve is constant, so the instantaneous acceleration anywhere for any time value between 0 and 5, not inclusive, is going to be 3 meters per second squared. Alright, now we reach the time interval from 5 to 10. If we look here, our slope here is 0. Our slope is flat. So all we have to do is go back down here. We'll find out where 10 was. That's 5, 6, 7, 8, 9, 10. We'll put a mark right here. So that means what's going to happen now, we're going to draw this. This comes back to 0. Do that again. That needs to be horizontal here. Come back. Now we're going to go all the way over to here. And we'll go ahead and color that blue. Okay. So again, this is what our acceleration versus time graph is going to look like for the first 10 seconds. Alright, now the other one. And here we have negative slope. We're declining. So we need to find out, again, doing basically the same thing we did here. I'll do this in black, and I'll do this, we'll do it over here. Find out what this time interval is going to be, or excuse me, find out what the velocity is going to be here. It'd be negative 15. I'm going to subtract what's my velocity here, which is 20. I'm going to divide it by the change in time. My time interval here was going to be 12. My time interval here was 10. When I do that, I'm going to get minus 35 divided by 2, which gives me a slope of minus 17.5. Okay, that's going to be the acceleration of my particle between time intervals 10 and 12. I drop down here, I find my time intervals of 10 and 12. I'll do that in red. We know this is 10 here, my time, 12 here. So I need to drop down to negative 17.5. So let's see if we got that in the chart here, or in the graph. We got 12, 14, 16, 18. We can squeeze that right in there. So we come down here, we put a little dot right in the middle, and we put a dot right here in the middle. Again, I should be a little bit closer to the lower line. Actually, let's do that too, because we got to make it really pretty accurate. Because 17.5 is not halfway between 16 and 18. So more right about in here. Okay, so I go back to my graph, and I'm going to draw a vertical line between here all the way down to here. We draw that over to here. We'll change that color again to blue. Okay, and we're getting close to being done. We go back here and we say, now what is the slope of my velocity versus time graph between 12 seconds and the end of this time interval? It's going to be 0 because my slope is horizontal. So all that means is my graph here has got to return back. And that's it. That's your whole acceleration versus time graph. Again, when you're given a velocity versus time graph, the acceleration versus time is going to be pretty easy to do. The displacement versus time graph is going to be a little bit more complex to do. Now, okay, so now let's just reiterate and go back over this. The area under here, the area under the acceleration versus time graph, will give you the numerical values of your velocities. If I wanted to find out whether or not this was going to be 20, all I would have to do is calculate the area under here. Now we can do that very quickly because we knew what this was 3. That gives me 15. Well, I started out at 5, so if I take 5 and I add 15, that gives me back to 20. Alright, again, you have to go back to the initial amount. So the same way here, your area here would be 0. Well, you knew we already calculated that here was going to be 5 plus the 15, which gave me the 20. So my area does not change, so this just goes straight over like that. Okay, so that's the way it's going to work. The area under this curve will give me these numerical values. The slope of this curve will give me the numerical values you have here. Same way here. The area under this curve here
will help me generate the numerical values of this. The slope of my displacement versus time graph will represent the same values I have here. All right, and that's it. Best of luck with these type of problems.